Today, we are diving into one of the most incredible Earth observation missions ever put together. It's called NISAR, and it's basically a high-tech checkup for our entire planet. But that brings up a pretty huge question, right?
I mean, really think about it. The Earth is this enormous, living, breathing system. How on earth could you possibly keep track of its vital signs? All of them, all at once, and all the time. It seems almost impossible.
Well, the answer is this amazing piece of technology called NISAR. It's a joint effort between NASA and the Indian Space Research Organization, ISRO. And honestly, it's a total game changer for how we understand our home. All right, so why do we even need this new eye in the sky? What makes NISR's viewpoint so different and so incredibly important, especially right now?
You know, the thing is, our planet is always moving, always changing. But a lot of the most critical shifts, like the ground ever so slightly swelling before a volcano blows, or a whole city sinking by just millimeters a year, are completely invisible to us. That's where NISAR comes in. It's built to see these tiny, slow-motion changes, giving us the power to better predict disasters, manage our resources, and really get a pulse on the health of our world.
So how does it actually do all this? To pull it off requires some seriously mind-blowing tech. So let's peek under the hood and see what makes this satellite so, well, super.
Okay, the magic here is something called synthetic aperture radar, or SAR for short. Now, unlike a regular camera that just soaks up light, SAR is way more active. Think of it like a bat using echolocation. It sends out its own radar pulse and then builds an incredibly detailed picture from the signals that bounce back. This is its superpower. It lets it see right through clouds, smoke, and even total darkness. Day or night, rain or shine, it doesn't matter.
But wait, it gets even cooler. And I saw it doesn't just have one superpower. It has two, working together. NASA brought the L-band radar. Its longer wavelength is perfect for seeing through the tops of forests to measure things like soil moisture underneath. Then, ISRO brought the S-band radar, which is much better at looking at things like crops and lighter plants. It's like having two different kinds of X-ray vision, giving us a complete, layered picture of what's happening.
The engineering here is just staggering. Get this. It uses a technique called sweep SAR, which is like taking a giant digital paintbrush and sweeping it across the Earth to paint a picture 240 kilometers wide in one go. And to do that, it has to unfurl a huge mesh antenna in space that's 12 meters across. That's almost as big as a school bus, all while screaming through orbit at 17,000 miles an hour, 743 kilometers above our heads. Just wow.
So, what do you think it costs to build something with these kinds of abilities? Well, the final price tag is about $1.5 billion. And yeah, that number is a big deal because it makes this the single most expensive Earth imaging satellite ever built. Let that sink in for a second. It's a pretty clear sign of just how vital this kind of data is for all of us. Now, a project this huge, this ambitious, this expensive, you just can't do it alone. It took a truly global alliance to make it happen.
And the teamwork here was split beautifully. You can think of it like this. NASA provided the science eyes, that L-band radar and the giant antenna, while ISRO built the satellite's body, the bus, and gave it the ride to space on its powerful GSLV rocket. It's really a textbook example of a true 50-50 partnership.
And you have to understand, this is so much more than just a cool tech project. It's a huge diplomatic and scientific milestone. It really marks a new chapter of partnership, where two of the world's top space agencies are pooling their absolute best skills to solve a problem that affects every single one of us.
All right, so the satellite's built. The teams are ready, but now comes maybe the most nail-biting part of the whole thing. Getting this one-of-a-kind, billion-dollar machine safely into orbit.
The whole mission kicks off from Sriharikota, India, launching on an Indian GSLV rocket. And this launch is historic. It's putting the satellite into what's called a sun-synchronous orbit, which is a really tricky target. Basically, it means the satellite passes over any given spot on Earth at the exact same local time. Why does that matter? Well, imagine trying to spot tiny changes in a photo if the shadows were different every time. It'd be impossible, right? This consistent lighting is the key to everything.
So here's how it's all going to go down. After a long countdown, we got liftoff. Just about 19 minutes later, boom, it should be in orbit. But it's not done yet.
Then begins a careful 90-day checkout. That's when they'll slowly unfold that giant antenna and make sure all the instruments are perfectly tuned. The real science is set to begin about 3 months after that.
Okay, success. The satellite's up there, the systems are humming. So now what? What does all this actually mean for us down here on the ground?
This is where the magic really starts. The mission has a rhythm. Every 12 days, like clockwork, NISAR will have completed a full scan of almost all the land and ice on Earth. And the precision is just mind-boggling. It can spot changes on the surface down to a single centimeter. That's about the width of your pinky fingernail. From space,
So what can you do with that kind of data? Well, this is where it gets real. We're talking about giving communities a heads-up days before a landslide, because we can see the ground starting to shift. Or helping farmers find groundwater during a drought, or tracking exactly how fast glaciers are melting. This isn't just abstract science, it's a practical tool that will help save lives.
but you know what might be the most revolutionary part of this whole mission? It's the data policy. All of this information, all these planetary vital signs, are going to be free and open to everyone, and fast. This completely changes the game. It puts this critical knowledge into the hands of not just big governments, but university researchers, local emergency managers, even you.
And that brings us to the final and maybe the most important question of all. For the very first time, we're about to have this continuous, crystal-clear view of our planet's health. Having this knowledge is one thing. The real test is, what will we, as a global community, choose to do with it?